Yeah, I can't do that. I gotta do it on. Oh, no, we didn't get there. Yeah, the wording keeps confusing.
All right, guys, let's take a look here.
These are pretty much the exact kind of questions I like to ask on a quiz. All right, so number one, they break the population up into groups. So it's one of two things then, automatically. It's either going to be stratified or cluster, because they both start off the same way. They break the population up into groups. Here we took some from each group. So that must be stratified. Some from each is stratified. I love it. The other one is cluster. What would be, how would you make this cluster? Yeah, if you took all of the people that were heavy wine drinkers and don't drink, maybe. Right? That's where you randomly pick two groups and they take everybody from those groups. That's cluster. Why wouldn't that make sense in this kind of a study? Why do you think they did it the way they did? What are they trying to get at here?
So they have a control point?
Yeah, it's like a control group. The light, I mean the people that don't drink. But then they have the light and the heavy so they can see if there's any difference in how much wine you drink. Right? Supposedly there's the thing right now, I think it's still true, because you always have to wait a week and see if they change their mind. But if you drink a little bit of wine each week, it helps you. Right? And it was like, more is better with it here. Some from each. Bam. Now, the reason I state this question the way I do is people just end up giving me a definition. That's not my intent ever. In this situation, what's a sample in the population? So, if you write, all right, number one, population and sample are groups of people or things. So if your answer is the relationship between drinking wine and stomach cancer, is that a group of things or people? No. So that doesn't make any sense. Your answer must be a group of things or people. That's what sample and population is. One of them is everybody, and the other one's a subgroup. So the second thing is, if your population was wine drinkers, why does that not make any damn sense? Since I picked my sample from my population, I picked people that don't drink wine. How did I magically do that? If I'm only considering people that drink. Is everybody with me? So really, where am I picking these people from? Yeah, so it's all Ecuadorians, or all the people in Ecuador, if you're not sure how to reference people from Ecuador. I'm not even sure if that's true. Anybody from Ecuador? Are you an Ecuadorian? Ecuadorite? I don't know. So the population would be all people in Ecuador. If you just said all people, that's a problem because they're only concerned with there in Ecuador. So the sample is going to be, you can say this a few different ways. How did somebody say their sample?
141 randomly selected people.
I like it. So one way is to add them all up and just say that many randomly selected people.
I put like each group.
Yeah, or you could just say 41 heavy wine drinkers, 52. Yeah. Either way, because that's the sample. So what was that, 141?
Yes.
Randomly selected people. Randomly selected Ecuadorians. Today's a really good writing day for Jeff. 141 randomly selected. Did I have some wine this morning? All right. What is just to make sure, because somebody asked me a question, and this is always interesting on what students focus on and don't. parameter and statistic, they both are the same thing. They're an average or a percentage, maybe some other things later. They both are the same thing, but one talks about the population, the other one talks about the sample, right? So don't say because it's a percentage, it's this. No. It's a percentage, great, but what's it referencing? What's it describing?
Sample.
Sample. So therefore it is a statistic. I love it. Stat describes sample. Okay, cool. All right, and then everybody's favorite problem. So the reason I do this to you, I'm not going to grade this, obviously, because I'm telling you the answers right now. So don't come down to me about giving you 2B. My purpose here is to make you realize I can do a lot of shit once I get a list of data. I can analyze in all different kind of ways. Are you guys with me? But this question is specifically about the data itself, right? The variable. I don't care that I got a percentage. What did I go ask people? Or what did I look at for part B? Just to start with part B. Hair color, right? So, and what level of measurement is that? Nominal, right? I don't care if you think that blonde should be first. There's no inherent order to hair color. So it's just nominal.
Well, why though? Because can't you find out, like, if you divide them, you can find out that there's more blondes than there are brunettes.
What's blonde divided by brunette? So really, there is a way to describe this, so I'll accept a different answer. So what are you considering your data to be? What do you mean when you say divide them?
The number of blondes.
Ah, okay, so if you said my data was the number of blondes and brunettes I see in a room, then what level of measurement would it be? Ratio. I love it. Do you see why I asked you to explain your answer? If you say that, if you say because I can divide the number of blondes by the number of, then that's what you're considering your data to be.
So that would work.
That would work. It depends on how you describe it. Because then what am I writing down on my list of paper? Numbers. Let me count the blonde. Let me count the brunettes. Or I'm thinking about what hair color do you have? What hair color do you have? Were you born with? Let's say.
So let me ask you this then. In your data here, you have the hair color, not the number of. But what if I put in my answer the number of blondes divided?
That's what I just said.
So
then it would be
even
fun.
in this specific example.
Totally.
Okay, cool.
Yes. Cool. I like it.
Well, that blew my mind because as soon as I saw percentages, I was like, okay.
I know, but the percentage is what I did with the data. It's what the data was that's important for this. Because once I really, now this is a small point, but I want to make this point. You have data you collect. What are you going to do with that data? Oh, you could do so much stuff. So it doesn't matter what you do with it afterwards. That doesn't change what the data's level of measurement is. Now, if you consider the data to be numbers of people, that's ratio. If you consider the data to be hair colors, that's not. I love it. Yeah?
So do you always recommend to just ignore the number part of it?
Yes, pretty much. You ignore what they did with the data. You look at what the data itself was. What's the question that you would have asked to get here? That's what's the level of measurement.
Can I explain that this ratio, because 0 would be 0 if I'm looking at it 0% of who I saw were blonde, as in there
But
was
see, that's not,
one.
still rough, that's not telling me what your data was. If the data was number, and you said there's 0 people that had blonde hair, oh cool. Then you're thinking of it as number of people with blonde hair, I love it. Big ass. Alright, what about part A? There's a few different answers out, except here we talked about this specific one yesterday. You could either, it's definitely at least ordinal. Because otherwise they would just call your name. They wouldn't give you a freaking number, right? It's definitely at least ordinal. Who said something different? I know somebody did, because you asked me about it. I told you it's fine. Where'd you go? Interval. Why would you say interval?
Because you can see that if someone has a smaller number than you do, then they...
How many spots ahead of it? Yeah, exactly. So if I'm H8 and somebody's H6, they're a couple spots ahead of it. So, and that's how you would explain it. So depending on the way you explain it, I would accept ordinal or interval. Ratio doesn't make a damn bit of sense. Because there's nobody 0, right? That I know of. You guys with me? And nominal's not good enough. It's more than just a name, it's at least ordinal. But the explanation is key. If you don't explain it, you lose most of the points. Okay. This would be ordinal or interval, depending on how you explain it. No, pick one. Yeah, whichever way you want to look at it and explain it, that's the answer. I like it. This one is the one we just talked about. The fish weighed 2 kilograms. Totally continuous. I don't care that 2 is a whole number. I don't give a shit. Did the fish weigh exactly 2 kilograms? That is as close to impossible as you can have, to be honest. It could be 2.000000034 or something, but it's almost impossible exactly 2. So I bet you it could be anything. Any fish could have any weight anywhere between almost 0 up to, I don't know how heavy the heaviest fish is. So this is completely continuous. Skips no values. What about this one? What's the thing to ignore here? 2.3 average. You ignore those things. You think about what are you going to ask people? You're going to ask people how many TVs you got. So what is that? Discrete. You can count them. I don't care if this TV is in parts, it's a TV or it ain't. Yes?
For the fish one, if you put continuous and I just put like, because it's an infinite amount of weights, it could be.
Say again?
Just write that.
Say again?
For the explanation for the fish, if I just put it could be an infinite amount of different weights. Is that?
Oh, there's an infinite number of possible values. Yeah, it's fine. Yeah. All right, I like it. What about 4A? That's obviously what? Systematic. And sometimes these explanations are going to be very quick. It's actually going to reference the definition mostly. Why is it systematic?
Because
Every nth. I like it. Systematic. Automatic. What about this one, the soybean field?
Plus.
Ooh, interesting. Yeah, it's interesting. So it's divided into subplots. All right, so right there I've got more of a process going on. So it can't just be random. It's got to be one of these processes. So it's in the group, so it's going to be stratified or clustered.
Some from all.
Some from all. So that's stratified. If I would have taken all the plants from some soy plots, from some subplots, that would have been clustered. Some from all or from each is stratified. Stratified, some from all. Woo! Okay, I like it. You guys want to take a break? I love you guys. You're lying. I'm not really sure. I'm cool with continuing. I'm okay with that. All right, let's do it. Let's continue. We'll take a break in a little bit. Any questions on that sheet left over? No? Okay. Can somebody turn the lights back up? Thank you. All right. So chapter 1 is all definitions, except for the relative frequency and all that. So we're going to talk about that right now. And I'd like to talk about it when I talk about chapter 2, because that's where we use that stuff to make displays. Chapter 2 is all about something called descriptive statistics. States. You have two main types of statistics. You have descriptive statistics, which is the ones we're used to, the pie charts and the bar graphs, right? And then you have something called inferential statistics, which is kind of like the 44% will vote for this guy, 42% for this guy, plus or minus 4%. So I'm inferring something about the whole population based on a sample I took. So chapter 2 is all about descriptive. You take a sample and you're going to describe the sample to somebody visually. How are we doing so far? You guys all right? So it makes sense to call it descriptive. Sometimes math people call things words that make sense. Sometimes we don't. I agree with that. So one of the most basic ways to describe a sample is to create something called, believe it or not, a stem and leaf plot. Yes. I think the book calls it that, or it calls it a stem plot, which is a little less interesting. So let's see what the shit this thing is about. So let's say I'm going to make up some data right now. Sure. Okay. I like it. All right, so write those data points down. By the way, I appreciate there's 19 people that have done the survey so far. I sent an email out this morning. I forgot yesterday. I get a lot of my data that I use for quizzes and tests from your responses to those. So don't forget to get in there and do those surveys. So I send an email out to remind you. Because I don't like, I mean, what does this represent? Numbers that came into Jeff's head. I love it. It's a little boring, but oh. So here's what a stem and leaf plot looks like. This is why the name is kind of beautiful. I have stems and leaves to these numbers. What aspect of these numbers is repetitive? Kind of repeats.
Double digit.
All right, so every number is a double digit, but within the data itself, what's repetitive?
1, 2, 3.
Yeah, so there are some in the 10s, there's some in the 20s, some in the 30s, right? So those are going to be my stems. My stems. So my stems will be 1, 2, 3, 4, because the highest number is 40-something. So this is the quickest, most basic visualization of some data. Stay with me now. Some of you guys are looking at it like, what the shit? What numbers do I have in the teens?
4 and 7.
A 4 and a 7. So 1/4 means 14. 1/7 means 17. You guys see what I'm saying? It's that simple. Then you keep going. And you kind of put it in order as you do. It's kind of a way to get data in order semi-quickly. So what about my 2s? What's my lowest 2 here?
1,
You get 21.
4,
4.
5.
Somebody back there was way ahead. I like it. 1, 4. No, it's good. I'm not trying to say bad things. And what about the 3s?
I guess 8 for the 2.
Oh, the 8. Thank you. What about the 3s? 5, 9, and then the 4s. 2. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8, 9, 10. All right, sweet. Now, if you just stop here, is everybody cool? Did everybody get the idea? Very simple idea. Yes? Now, to be honest, if I saw this out in the wild by itself, this could mean 1.4, 1.7. It could mean 104. It could mean 1,400, 1,700. So your answer is not complete until you put a key down. You got to give me a way to read this, because I'm not going to see this. You're going to give me this. It's a way to visualize your data quickly. So what's the key going to be here? The keys for this one is going to be 1, 4 means 14. Now please don't keep going. 1, 7 means 17. 2, 1 means, no. I just need 1, and then I can figure it out. It kind of defeats the purpose if you do it for every one of them. Are you guys with me? Obviously that's happened before. Just want to stop you from doing that. Now real quick, watch this. Watch you do this. And you can see that, you don't have to really do that. If these are ages, most people are aged in their 20s in this group. You guys with me? So it's also another quick kind of so you can see how your data is distributed. How are we feeling? All right, so that's beautiful. You gotta love that. It's not gonna stay that easy, so don't get too excited. Okay, so what we're gonna get into now, I just want to get that sucker out of the way quick. It's this little stem and leaf. That's nice. It's beautiful. What I want to do now is focus on histograms. little side notes. You guys have seen bar graphs before, I'm sure, and you've seen histograms too. A bar graph, there's no two G's, Jeff, that's me. Bar graph is for qualitative data. What the hell's qualitative data?
Dealing with quality and not quantity.
Exactly, and I heard somebody say categories. I love it. So that's non-numerical data. So you've seen stuff like Hyundai, I just like to say Hyundai, BMW, Ford, right? In fact, is it okay that I put them in this order? Of course, who gives a shit? They're just car names. You with me? And what does the height mean? This is not a good bar graph, by the way, yet. What information have I left off?
Everything.
Like I said, sales.
I've got names here and little bars. Scale. I love it. Right? So like, I don't know. Doesn't matter. So this is like 10, 20, 30, 40. So these are cars I see in a parking lot somewhere. You guys maybe, so the height represents the number of things. I like it. So a histogram is just the same as a bar graph, but it deals with numerical data, like the distribution of ages, which means there will be a scale here also, because then it's numerical. Are you with me? This scale, there's no scale here really, it's just names. Who gives a shit, right? I like it. He says shit a lot. Oh well. Okay, so let me ask you right now. If once I get this thing going, it's gonna be a while. You guys want to take a break right now? Or no? I'm cool if you don't. We'll just keep going. I love you guys. Huh? Keep going. I like it. All right. Let's do it. So just bear with me. First thing is, this is gonna sound a little weird, and I don't obviously care, because I'm a math teacher. I always sound weird. But let's say I wanted to take this wall here. I'm like, that's puke orange. Let me take this back to the 70s. I want to put some wood paneling up here, right? You guys with wood paneling? You guys cool? Like slats of wood, okay? And they can be different widths. I'm gonna make sure you guys are with. Some of you guys are like, are we in carpentry class now? No, we're not going to do this. This is, believe it or not, what I'm talking about right now deals with the math we need to understand for one of the first steps of creating a histogram. I like to make the math physically representable as often as I can. All right, here we go. All right. So let's say, how long would you say this wall, this part is here? I got to imagine stacking people 1, 2, 3, 4. So I'd say let's say 36 feet. Does that sound all right? Okay. Just imagine 6-foot people and laying them on the ground. Is everybody with me? Yes. So let's say I want to cover that wall using, let's make it interesting, using 5 wood panels. Okay, so what do we got? It's 36. Now, if I use 4 wood panels, let's use 4 first. 36 feet long, and if I want to use 4 panels, how wide would each panel have to be? Okay, do you see how that's not hard at all? You guys, of course they have to be 9 feet long each, or else it's not going to cover the whole damn thing. You guys with me? Okay. So this would lead to 9 feet for each panel. Okay, right? Now let's say this. Let's say that it's open on either end, so I can over cover it. You guys understand? So I could jut out at one end if I need to. I'm just kind of OCD. I need each panel to be the same width, or else I go a little crazy. But it's open, so I can over cover it. I just don't want to see that orange anymore, so I don't want to under cover it. You guys with me? So what if I had 36 feet, and for some reason I have to use 5 panels? Right, because I'm a member of a religious cult and 5 is sacred. So I don't know. What am I going there for? I don't care. So they're 6 feet long, and I want to use 5 panels. Over covering is fine, under covering sucks. How many panels? Or how wide will each panel be? 8. Yeah, 8, because 7 would be too little, right? So if you do 36 divided by 5, you get and then I round up to 8, right? So that will cover. I could make them 7.2, but I'm going to use whole numbers to make my life easier. All right, let me stop for a second. Everybody understand the math involved with the physical thing? Okay.
When you round down 7.2?
If I round down to 7, then, yeah, so be careful. When I say round, I don't mean the official round. I can round up or round down always, if I wanted to. Officially, if I rounded this number mathematically, it would be 7. I'm going to round up because I don't want to undercover, because that orange offends me, right? I like it. Okay. I don't mind the orange, to be honest. Now you're all going to think about that orange every day you come in here. Okay, so let's do a problem. Please, your God, Jeff, show me how wood paneling and orange walls deals with some problem I've got to do, right? That's what you guys are all thinking. I don't blame you. So let's make up some more data. I hate making it up, but I don't have enough data from you guys yet. So here we go. I'm going to do one other thing that's not always going to be true. I'm going to put the data in order for us. It's going to make it a lot easier, right? This was a little group of data I had up here earlier, so it wasn't that big of a deal that it wasn't in order. But when it's not in order, it's really difficult to put things in the right place. I like it. So one big thing we're going to learn first on the calculator later today is how to make that $100 thing sort numbers for me. You should be able to do that. All right, so here's some data. Here we go. Some data for us. Is that still going? Yes. Let's see. Let's do ages again. Why not? Okay, that's good. Sure, why not? So write all those down. This is really exciting. The worst part about statistics is getting your data, dealing with the freaking data, right? All those work from home, make so much money a week, that's data entry jobs. These data entry jobs suck. 7, 14, 7. Oh, shit. All right. Oh yeah, I got one color today because I don't think purple. Are you gonna work purple? Okay. So the first thing I want to ask you is the length of that wall is the first thing I was concerned about. When I create this picture is going to be, it's going to look like this. This is my goal for this histogram. It's going to look like this. Something like this. And then this, what do you think this is going to be? This first number here. For this data. 16. And the last number, to be honest, doesn't have to be 42, because remember, I can overcover stuff. I just need somewhere for every data point to get to go in. All right, stay with me now. We're just getting into this. So what's the equivalent of the length of the wall in this case? It's going to be the spread of the ages. Right? Which sounds weirdly like a song, spread of ages. So in statistics, we call it the range. So how far does my data range? 42, 16 to 42, so 42 minus 16. So the range is high minus low. $26. Okay. So that's sort of like our 36 for that wall, right? Now, next big thing. This wooden slats, do you see how they are these? They are the rectangles, right? Which is why that physical analogy works really well, I think. We're going to use between 5 and 10 slats, right? So use 5, and I'm going to call them classes because that's what they are. 5 to 10 classes. So I'm going to separate people into classes, in this case based on their age. Is everybody with me so far? So instead of calling them wood slats, I'm going to call them classes when we're talking about data, right? But physically it's the same idea. So how can I tell how wide each one of these is going to be? Do the same thing we did over there, right? Well, how far do I have to go? 26. Is this a lot of data? Is this a huge collection of data? No, so I'm going to use 5. Everybody use 5 classes. You would only use 6, 7, 8, 9, 10 when you get a bit more and more and more data. So we're almost never going to use 10. I'm not going to give you like 300 data points to do. That would just be insane. Right? Give me 10 years. Maybe I'll be there. So if these are classes, and this is how wide they are, let's call it freaking class width. Right? How wide is each thing? So I'm going to call it class width. That's how wide each rectangle is going to be. I love you guys. We're getting there.
6.
Yeah, so how'd you get there?
26 divided by 5, 5.3.
Yes, range divided by number of classes. So 26 divided by 5. I don't know if you guys remember the shortcut divided by 5. Didn't we talk about that yesterday? Double 26 and then move the decimal back once. So that's 52, so it'll be 5.2, and then you round up like we talked about earlier. Please, dear God, don't use the decimal number. Don't do that to yourself. Right? It's not wrong, really, but man, don't do that. You'll see why in a minute. Okay. Now I'm going to show you 2 ways to do this. The first way I'm going to show you is the textbook way. This textbook. And the other way I'm going to show you is the way I was taught. And you can do either way you want to. I don't care. Right? Just the textbook way sucks, but that's okay. Sorry, I can't be. But no, it's fine. It's fine. It's fine. But hopefully some of you guys realize it sucks. So what do you think is the next important thing to figure out?
What goes in each class?
Yeah. What defines each class, right? So 16 to what is going to go in the first class and so forth. Now, we got to be really careful here. If I do 16 and then I just add 6, because that's my width, that's not really right. If this starts at 16, where should the next class start if it's 6 later? The next class should start at 22. Now, can I put a 22 here also? Why is that wrong? Where the hell would the 22-year-old go? Which class? I don't know. So that's the textbook way. It's got a little bit of trouble. You got to be careful. So I always do the width here. This has got to be 6. Why? Because that's what I calculated it was going to be. If one class starts at 16, the next one better start at 22 because the width is 6. Are you guys with me there? Now you can't have these be the same number because then where would I put them? Where would I put them? My like 5th puberty right there. Now you just keep going by 6. Now it's really easy. Just keep going by 6 here. This would be 27. Add 6. Add 6. Add 6. Add 6. Add 6. Add 6. 1, 2, 3, 4, 5. Does the last data point have a home? What's the highest data point? 42. Does it have a place to go? Yes. Is it in between 40 and 46? Did I have to stop at 42? No. I just need to have everybody have a home. Did I have to start at 16? No. You could have started at 15 if you wanted to. I don't know why you would. But every data point just has to have a place to go. I love you guys so much. You're all looking at me like, really, dude? Yeah, really? Okay. So these are my classes. This is going to be what we call, now this is the stuff from chapter 1 some of you guys have already done. The frequency and then the relative frequency. The freak and the real freak. Now for some reason I always get, yes?
There is no 22 in the data. So why do
Oh, it's okay. I know. But there could be, couldn't there? Is there a 28? Yes. So I wouldn't want to put 28 here.
Okay.
Yeah, so you can't, you do it in general always. You don't do it just because in this one it's going to work okay.
Okay.
Okay, I like it. So these are what's called, all right. You'll see why. I'm going to show you the textbook way in a minute. People don't like, I'm going to show you the way I was taught in a minute. People don't like the way I was taught because it has inequality symbols in it. Ooh. But you've taken algebra. You shouldn't be freaked out about that, but we'll see. There's a limit to me, right? I stop right here. This is where I stop, right there. Jeff stops here. This is not Jeff. This is Jeff. You with me? I love you guys. You're like, what the shit's wrong with this guy? What did he take this morning? So this is my limit. So these are what's called class limits. Then there's a boundary. Sort of like if you get up, I don't want to get in your face, but if you got like right here, there's going to be a problem. There is a problem. Do I like you like that? Do you understand what I'm saying? So we have a limit. I don't exist beyond my skin here. Then we have a boundary where only my closest friends or my loved one or whatever can get in there. Are you with me? Because what's going to be the issue when I go to graph this? I can't do this. I can't say 16, 21, 22, 27. Because I cannot have gaps. If I have gaps, it makes it look like I've skipped people or there's nobody there. There can't be gaps. No gaps. I know. Stay with it. That's why the textbook method sucks. But you can do the textbook method if you want to. It's fun. So really, what I have to do is I'm going to have to plot 15.5 up to 21.5. So if I go down 0.5 and up 0.5, what happens here? I go down 0.5 to what? 21.5. So now, will there be a gap? No. So if you want to do the textbook way, you have to be comfortable with that shit. So please understand, nothing wrong with that. It's an acceptable way to create histograms. Nothing wrong with it. Before we keep going, let me show you the way I would do this. My classes would look like this. It's not really my way. I didn't create it. It's just the way I was taught. So my way would say 16, 22, 22, 28, right? So forth. What the hell does this mean? Where does 22 go? There's no ambiguity here. Where's 22 go? Where's 22 go? In the first one and the second one. Here the x's can have to be less than 22. Here they can equal 22. Here we go in the second one. And so forth. Doing it this way would not change anything later at all. It's just that my limits are my boundary. I don't have to worry about the 0.5 shit. You just have to worry about x's and inequality symbols. Now, if you don't like those, do this way. Then you got to worry about the 0.5 business and all that kind of stuff. Sort of a give and take here, right? Some of you guys look really like, what have I done to myself? Okay. No matter which way you do this, how many things are in here? And for some reason, I always have somebody do this. 5, 5, 5, 5. 21 minus 16. No, come on. How frequently does data show up between 16 and 21? 3 times. All right, what about 22 to 27? 5 times. 28. Everybody cool? Everybody with me? That 5 is right, just because it is. What about 28 to 33? 3. I like it. 34 to 39? 4. And then the rest. 3. That's an interesting distribution. Interesting distribution. How's everybody doing? Just to remind you guys, if you have a question, at least 10 other people have that same question. If you speak up, you'll be their hero.
Can you do the same thing for your way?
It's the same thing. Isn't it? You guys see how it's the same numbers. Doesn't matter. The reason this is better is if my data had decimals, where would 21.7 go, for example?
It'd be different though, because yours, the 28s wouldn't go in the...
Totally different.
Oh, they're going third.
There you go, because it's the equal sign.
not?
22 would not go here, it'd go here the same way as there.
So literally the only difference is that you have to put the Western.
Yes, totally.
Oh.
And it kind of makes me a little bit sad that people don't do this way just because of this. You took algebra, you should be cool with it. But you don't have to do it this way. You can do it this way. I'm not going to think less of you. No. Do you understand what I'm saying? I'm not going to give you kudo points for doing this. I'm not going to go, oh, +1. No, screw that shit. Either way you do it, you've got to get it right. I don't care. You pick which way you want to do it. Yeah.
So then the only difference is your histogram, is it gonna have decimals in it?
If you had decimal data, I'm not even going to show you. This would so suck. I'm not even sure. This would so suck if you had decimal data, because then you'd have to go out to decimals, and then your limits would go out to the second decimal place. Your boundary, sorry. I don't even want to go there.
Are you going to give us decimal data?
No. No. Yeah. Are you? What's up?
So how does it look different when it's
Okay, I'll show you that too. We'll get there. Yes.
So in your way, even if they have decimal data, where that?
Wouldn't matter. It's where would 21.7 go? Here. Here, where's 21.7 go? It's above 21 but below 22. So then I'd have to do like 21.5, and then my boundary would be 21.55. Do you understand? Oh Jesus. Or something. It's gross. Okay. We got whole number data. Let's focus on that. So how do I get my relative frequency?
Divided by the total number.
Yeah, so it's really just a percentage. What's my total number? 18. So what's the relative frequency here? 3 out of 18. I think that's right. Check me on that. Just do that. 3 divided by 18, right? Is everybody with me? Anybody with me? You guys all right? Yes. Are you with me? Okay, I got you. And then this would be 5 out of 18. What's that? I don't know. Nobody's going to help me. I think it's 0.27. Say 27.8. And then I already know 3 out of 18 is 16.7 because nobody told me I was wrong. 4 out of 18 is 0.222, so it'd be 22.2. 22.2. 3 out of 18 is again 16.7%. How do you kind of check yourself? Check yourself. Does it always have to be, what should it always be close to? 100%. What is acceptable is 99 to 101 roughly, right? Because I might have rounded more up than I did down, for example, just because that's the way it came out. But when you add these up, what do you get? I think you get 100.1. Is anybody going to check me?
Yeah.
100.1%?
Yep.
All right, so don't just stop here and say it's invalid. No, that's fine, 100.1. We rounded up more than we did down. Okay, all right, so now how does this translate into a picture? And then we're going to definitely take a break because now I want to take a break now. So it's just going to happen.
Do you want to do percentages or in decimals? 'Cause I think
Percentages. Yeah, they both mean the same thing, but for humans, percentages are easy to think about. So I'd rather have it in percentages. For humans. I don't worry too much about cumulative frequency. You do it for chapter 1, you make chapter 1 happy, and then you forget. It's really the same stupid thing as this. Alright. And I do have a little handout about everything we've discussed so far in chapter 2 that you're going to work on probably after the break. So how do I get this thing put together? So this scale here, what's that going to relate to? In fact, I haven't even told you yet, so it's evil. I have to tell you to create a frequency histogram or a relative frequency histogram. Normally I'm going to ask for a relative frequency because percentages are the easiest things to grapple with, right? So I'm going to make a relative frequency. So what kind of scale should I use here then? How far up do I have to go?
To 100 and
I don't have to go to 100%. Definitely don't. Please don't do that.
Probably like 28 to 30.
In my highest percentage, yeah, I want to go up to 30 then. Right? If you go up to 100, then your whole picture is going to be like this. Right? It's a little too much room. So let's go up to 30. So what do I want to count by then, maybe?
5.
I like it. 5, 10, 15, 20, 25, 30. Good job, Jeff. What are these? What are they? Percentages. They're more officially known as real freaks, right? So put real freak. Label your axes. If you don't, you lose points. It's crazy. Like, but I know what it is. All right then, write it down. Shit. And then here, let's do the textbook way first. And then underneath that, I'll show you what my numbers would look like. Right? So the textbook way, what do I have to start officially? 15.5. Real quick, 21.5 minus 15.5 is 6, which is our width, remember? So when you do it this way, the width is hidden, because you have to look at the boundaries, not the limits. Please stay with me. So some of you guys are like, that's 5, I thought it was 6. No, there's 6, and there's 6. The freaking 6 is hidden. Another reason why, personally, I don't like that way. But if you do this way, you're fine. So I'm going to start at 15.5, and then I just add 6, because that's the width. Make sure I'm doing it right. Yep. Good job, Jeff. Add 6. Add 6. Oh, nobody called me out on this. What's 39 plus 6?
I don't want to say anything.
You're fine. This should be a 45. I make mistakes. I'm not one of those asshole math teachers. I'm the teacher, I don't make mistakes. I freaking make mistakes. Call me out. Don't be evil. But, call me out. So now that makes sense there. Right? There's some checks and balances. Is everybody cool with what's happened so far? Or, roughly cool with it? Kind of, okay. Kind of roughly cool. Okay. What's the label here? I didn't really say too much. I think I said they were ages. So in a problem, I'll have like ages of people waiting at a bus stop or something, right? But here I'm just going to put ages of people, whatever. You can say it was people, it could be cheese. Just don't forget the labels for those two. Now, how tall am I going to make this first bar? 16.7, yeah. So we're humans, we're not going to know that exactly, so we'll just go up to there. Try to make that match up. And then this one's going to be almost to the top. And then this one's going to be there again. And then this one's going to be 22, so roughly right there. And then this one is going to be there again. I like it. It's not very exciting, sorry. Right? An exciting distribution, can somebody explain to me why, go away, why this distribution would be a little more exciting? Yeah, that's called a normal. It's like a bell curve, right? Which, has anybody ever heard of the term curving your grades? That's where a teacher picks the curve up and moves it. So, like when I took my first exam in grad school, I got a 20 out of 41, and I thought to myself, what am I doing here? And the teacher said, good job, Jeff. I'm like, what the shit just happened? Right? Because the highest grade was like a 22 out of 40. So, he curved our grades. I got an A. Because he picked the curve up, and he just moved it up. That's what curving grades means. I don't know if you guys ever knew that. Okay. So that's obviously not normal, right? It's not a bell curve. It's almost flat in a way. It's almost what's called uniform distribution. Okay. So let's do this. Let's take a break officially. Huh? Oh, the only difference would be, this would be 16, 22, right? You just, 34, 40. That's the only difference. See?
Oh, it's positive.
Yeah, you don't have to worry about the 0.5s. if you do this in a quality way. Now, I love how people really get confused about, it's not that confusing, right? Hopefully. If it is a little confusing, don't do this way. Sort of like if you're not used to using your blinkers, just don't use them. Right? Get your blinker going that way and you go this way, screw you. So, all right, let's take a break. Let's come back 10 till. Come back 10 till. We're going to take that little field trip at the end of the class. That's the last thing we'll do is do the little field trip. Okay? All right.